Students, now we will discuss electronic circuit of OR gate. Now logic gates. There are three fundamental logic gates. Number one, OR gate. Number two, AND gate. Number three, NOT gate or inverter. It is also called inverter as it inverts the input. It converts 0 input into 1 and 1 input into 0. Now first one, OR gate. In circuit diagram of OR gate, we use the property of PN junction that in forward bias the resistance of PN junction becomes 0. That is, PN junction gets short circuit in forward bias, and in reverse bias the resistance of PN junction becomes very high. That is, PN junction acts as open circuit, means no current flow through it. Now to draw circuit diagram of OR gate, suppose this is a battery of 5 volt, positive terminal of which is connected to 2.0 to give input 1 to the OR gate, and negative terminal is connected to earth. Now this is for input A PN junction, the P type semiconductor of which is connected to point A, and N type of semiconductor of PN junction is PN junction D1. It is connected to earth through a resistance R, and across the R we get the output Y. The number of PN junction connected is equal to number of input given to the OR gate. We consider a OR gate with 2 input, so we use 2 PN junction. This is junction D1 and another input B connected to PN junction D2, and P type of semiconductor of which is connected to point B, and N type of semiconductor of PN junction D2. It is connected to resistance R or connected to earth through resistance R. So this is the electronic circuit of OR gate for 2 inputs. Now truth table of OR gate is, this is input A, input B and output Y. First case, when both input are 0, output is 0. Second case, when A is 0 and B is 1, output is 1. Third case, when A is 1, B is 0, then output is 1. Fourth case, when both input are 1, 1, the output is also 1. Now first case, when A is 0 and B is 0, that is, point A and B are not connected to point O, then both the PN junction are at same potential and are reverse biased. Both the junction across both the junction potential difference is same, or across the PN junction, both the PN junction potential difference is zero. That is, both P type and N type are at same potential, so no current flow through it. No current flow through the circuit, and potential difference across the resistance R is zero. That is, output Y is equal to 0 for A equal to 0 and B is equal to 0. Now second case, when A is equal to 0 and B is equal to 1. This is the second case. B is 1 mean connect point O to point B. So the point B is now at high potential at 5 volt. Then the PN junction D2 is in forward bias. This junction PN junction D2 is in forward bias, and current flow through PN junction D2 as shown. Current is flowing from point O to B and B to resistance R, and potential difference across resistance R is V is equal to 5 volt, or we can say it is at high potential. Therefore, output Y is equal to 1 for A equal to 0 and B is equal to 1. Now, third case, when A is equal to 1 and B is equal to 0. This is the third case. For this, connect point O to point A so that the point A become at high potential, or input A become 1 and point B is at low potential. It is input B is 0. Then the PN junction D1 is in forward bias. This is PN junction D1. This is in forward bias, and current flow through the PN junction D1 as shown. Current is flowing from point O to A, then through the resistance to earth. And potential difference across R is V is equal to 5 volt, or it is at high potential, or we can say Y is equal to 1. Therefore, output Y is equal to 1 for A is equal to 1 and B is equal to 1. This is our third case, and now we will discuss last case or fourth case. Fourth case, when A is equal to 0 and B is equal to 0. That is, both inputs are at 1. This is the last or fourth case. Then both PN junction now D1 and D2 are in forward bias. That is, D1 and D2 both the junctions are at forward bias. For this, connect O to B and O to A. A and B are at high potential. If P-type semiconductor is at high potential and N-type at low potential, then it is in forward bias, and current flow through both PN junction D1 and D2 as shown. See in the diagram, current is flowing through both the junction D1 and D2 from P-type to N-type. and potential difference across R is V is equal to 5 volt. Therefore, output Y is equal to 1 for A is equal to 1 and B is equal to 1. That is, Y is at high potential, mean output Y is equal to 1 for A is equal to 1 and B is equal to 1. So this is the electronic circuit of OR gate and working of this PN junction, this OR gate, working of this OR gate electronic circuit. Now, dear student, please share, like and subscribe it so that more students can take advantage of this channel. So thank you very much.